Imagine waking up to ash falling like snow, airports closed worldwide, crops failing, and a cold so deep that summer simply disappears. Now imagine that not one volcano, but every volcano on Earth erupted within weeks of each other. What would happen? Would humanity survive? Could modern civilization cope? Today we answer this terrifying what if with real science, historical examples, and climate models. This is High Info. Let's find out what the world would look like if every volcano on Earth erupted at the same time.
There are thousands of volcanoes on Earth. Some are quiet vents that release steam. Others are explosive giants capable of sending ash and gases high into the stratosphere. When scientists talk about eruptions that affect global climate, they focus on those that inject sulfur dioxide, or SO2, into the stratosphere, where it forms sulfate aerosols that reflect sunlight and cool the surface.
We have real cases that show how a single eruption can perturb global climate. The 1991 eruption of Mount Pinatubo cooled global temperatures by about ½ degree Celsius for 1 to 3 years. The colossal 1815 Tambora eruption triggered the Year Without a Summer in 1816. Crop failures, famines, and social unrest followed. Tambora injected tens of teragrams of sulfur into the stratosphere and produced long-lasting sulfate aerosols. For a still larger example, the Toba supereruption around 74,000 years ago has been modeled to possibly produce several degrees of global cooling. Some studies suggest drops of 3 to 9 degrees Celsius in parts of the world, though the exact climatic and biological consequences remain debated.
Eruptions produce three relevant things for the global impact: tephra, gases, especially SO2, and aerosol precursor particles. Ash falls out locally and can collapse roofs and destroy engines, but SO2 is the climate wildcard. When oxidized in the stratosphere, it forms sulfate aerosols that scatter sunlight and cool the planet. Current satellite-based top-of-atmosphere measurements estimate the largest detectable volcanic SO2 sources deliver on the order of 20 to 30 teragrams SO2 per year from subaerial volcanoes that are actively degassing. But explosive eruptions can inject tens to hundreds of teragrams in a single event.
If every volcano, every arc, every caldera, every vent erupted explosively in a short window, we would see three mere immediate effects. Ash in the troposphere and stratosphere. Widespread local and regional ashfall would darken skies, shut down flights, and choke machinery. Aircraft engines are vulnerable to ash ingestion. Modern aviation would grind to a halt. Huge SO2 injection into the stratosphere. Sulfate aerosols would form rapidly and spread globally, increasing Earth's albedo and plunging surface temperatures. Massive short-term particulate pollution, respiratory crises in cities, and agricultural collapse from blocked sunlight and ash-covered leaves. These impacts are not hyperbole. Scientists modeling extreme eruption clusters find that the climate response scales with the total sulfur injected. A planetary-scale multi-eruption would likely push sulfate burdens far beyond historical single events.
The key question is how much sulfate reaches and stays in the stratosphere. Large eruptions like Tambora produced sulfate loads that cooled global temperatures by about 0.4 to 0.8 degrees Celsius for a few years. Toba model simulations indicate regional cooling of several degrees and reduced precipitation for years to decades in some simulations. If dozens or hundreds of large eruptions coincided, climate models project multi-year cooling potentially of several degrees Celsius globally. That degree of sustained cooling would devastate agriculture, reduced growing seasons, increased frosts, and crop failures on multiple continents.
Human civilization's food systems are tightly tuned to climate. A multi-year volcanic winter would interrupt planting cycles and lower yields. In 1816, Tambora caused crop failures and food price spikes. Scale that up and modern global supply chains, just-in-time shipping, monoculture staples, become fragile. Add to that ash-laden irrigation water, livestock die-offs from contaminated feed, and transportation breakdowns, and you have cascading failures. Local famines become regional shortages, and shortages become geopolitical instability.
Ash clouds would force a near-total shutdown of aviation until ash settled. This could last months in some regions. Power plants, water treatment, and supply chains reliant on moving parts would suffer from abrasive ash. Insurance claims, stock markets, and energy systems would see unprecedented shocks.
Sulfate aerosols also change atmospheric circulation and sunlight reaching the ocean surface, cutting photosynthetically active radiation and altering ocean productivity. Ash deposition into the ocean can fertilize plankton briefly, but long-term cooling and reduced sunlight would stress marine food webs.
Not every large eruption has identical climate impact. Recent petrology research shows some magmas trap sulfur in minerals like anhydrite, reducing atmospheric SO2 release. The sulfur budget of an eruption depends on magma composition and oxidation state. So even big eruptions can vary dramatically in climatic effect.
Here's a likely timeline for a planet-wide eruption surge. Days to weeks, local destruction near vents. Ashfall begins, flights grounded, emergency response overwhelmed. Weeks to months, stratospheric sulfate forms and begins scattering sunlight. Skies dim. Agriculture in vulnerable regions suffers first. 1 to 3 years, global cooling peaks, reduced precipitation and harvest failures. Economic and social stress escalate. 5+ years, aerosols slowly settle out. Recovery depends on how much ecological and societal damage occurred, and if food stocks and governance held.
Could humanity adapt? Some measures would help. Strategic food reserves and diversified crops resistant to frost could buffer shocks. Ash cleanup protocols for critical infrastructure, power, water would reduce secondary failures. Geoengineering-style responses, intentionally injecting aerosols, would be misguided here because the atmosphere is already overloaded. What we need is targeted adaptation, not more particles. International coordination to reroute food, provide fuel, and maintain order would be essential. Small communities and nations with local food production and resilient systems would fare better, but global coordination is the real determinant.
So what is the short answer? If every volcano on Earth erupted at once, we'd likely face a global crisis, severe short to medium-term cooling, or a volcanic winter, catastrophic agricultural losses, widespread infrastructure disruption, and major humanitarian emergencies. The severity would depend on how much sulfur reached the stratosphere and how long aerosols persisted. But this scenario could threaten modern civilization's stability.
If this deep dive into a world of simultaneous eruptions fascinated you, and you want more science-based what-ifs that connect real research to dramatic scenarios, hit like, leave a comment, what would you want saved first, seeds or solar panels? And subscribe to High Info for weekly deep dives. This was High Info. See you next time when we ask, could humans survive a super volcano eruption?